Welcome to this video in which I'll be going through the solutions to the VCAA 2022 Northern Hemisphere Timetable Maths Methods Exam 1. So, the first question, question 1, part A, asks us to take the function y equals sine x squared plus 1 and find the derivative dy dx. So in order to answer this question, we're going to use the chain rule. And that is, to get dy dx, we're going to differentiate the outside, which is sine, and that's going to turn into cos. The argument stays the same, x squared plus 1, and then we multiply that by the derivative of the inside. Now the inside is x squared plus 1, so the derivative is 2x. So tidying that up, making it look a little bit nicer, the answer to that therefore is 2x cos x squared plus 1. And that's all you need for the 1 mark. Moving on to part B of question 1, we have f of x equals x squared log ex, and our job is to find f dash of e. So we need to differentiate f of x and then substitute in x equals e. So first of all, working out the derivative, f dash of x, we're going to use the product rule. So differentiate the first, which is x squared becomes 2x, times by the second, log ex, plus differentiate the second, log ex, that becomes 1 over x, multiplied by the first, which is x squared. So that simplifies to 2x log e of x, plus 1 over x times x squared is simply x. So that's the derivative of f of x. Therefore, the derivative at e is f dash of e is equal to 2e log e of e plus e. So just substituting x equals e. So we know that log e of e is equal to 1, so that's the same as 2e plus e, and that is simply equal to 3e. So there you go, 1 mark for the derivative, and then 1 mark for the numerical answer of 3e. So moving now on to question number 2, we are given a derivative f dash of x equals 2 over x plus 1 plus 2 cos x. We also given a domain of x greater than negative 1. So our job is to find f of x, the original function, given that f0 is equal to 3. Now, before I go any further, it's probably wise to rewrite that f0 equals 3 as 0, 3. It's just easier to write it as a coordinate. So, to get f of x, we need to integrate the derivative. So f of x is the integral, now don't forget your brackets, 2 over x plus 1 plus 2 cos of x. Integrate all of that with respect to x. So the integral of 2 over x plus 1, that's just 2 log e of normal brackets x plus 1. Just again, double check the domain is x greater than 1, so we can just write log e of normal bracket x plus 1. Positive 2 cos x, that integrates to positive 2 sine of x. And because this is an indefinite integral, we will need a plus c, the arbitrary constant of integration. Now that is done, we can then use the given coordinate. So when x equals 0, f of x is equal to 3. So that means that 3 is equal to 2 log e of 0 plus 1 is 1, plus 2 sine of 0 plus c. So you end up with 3 equaling. Now log e of 1 is just 0, so 2 times 0 is 0. 2 times sine of 0, well, sine of 0 is 0. 2 times that is, of course, 0 as well. So you just get 0 plus c. So this tells us that c is equal to 3. Now, we actually want f of x, not just the value of c. So therefore, finishing off, we will have f of x is equal to 2 log e of x plus 1 plus 2 sine of x plus 3. And there you go. That is the final answer. Moving on to question number 3. So in question 3, we have a marketing company that wants to estimate the proportion of the population who regularly ride bicycles for exercise. So that is the scenario we're looking at. We've got a sample of 100 people. So I'm actually just going to write n equals 100 just to start us off, and finds that 10 of these people regularly ride bicycles for exercise. So this tells us that x, which is the number of successes, is equal to 10. So using z equals 2, so we're given a z value, we have to find an approximate 95% confidence interval for the true proportion of the population who regularly ride bicycles for exercise. Okay, so we can look at the formula sheet and copy and paste the formula for a confidence interval. So in this case, the 95% confidence interval for us is going to equal the p hat value minus z times the square root of the p hat value multiplied by 1 minus p hat all over n, comma, and then the same thing just with a plus in the middle. So p hat plus this time, z square root p hat 1 minus p hat all over n. So we know the p hat value. Well, p hat is actually equal to x over n, which is equal to 10 over 100, and that's just equal to 1 over 10, or you can write it as 0.1 as well. So now let's look at what all we have and what we need to calculate. So p hat, as we just found out, is 1 over 10 minus 2, because we are told that z equals 2. 2 times the square root of 1 over 10 times 1 minus 1 over 10 is 9 over 10. And that all is divided by 100. Then comma, exactly the same expression, just with a plus. So plus 2 square root 1 over 10 times 9 over 10, and all of that is divided by 100. Don't forget to close the bracket. Okay, so this time what we've got is that's 1 over 10 minus 2 times the square root. Now let's quickly figure out what's going on here. 1 over 10 times 9 over 10 is 9 over 100, and 9 over 100 divided by 100 is 9 over, it'll be 4 zeros, so that's 10,000. Okay, comma, 1 over 10 plus 2 times, in this case, again, it's the same fraction, or the same square root, I should say. That's just 9 over 10,000 again. So, working that out, well, the good news is that the square root of 9 is 3, and the square root of 10,000, well, that's just 100. So what we have is 1 over 10 minus 2 times 3 over 100 is 6 over 100. And in a similar way, we'll have 1 over 10 plus 2 times 3, 6 over 100 as well. So what we now have is 10 minus 6 over 100, which is 4 over 100. Now 4 over 100 is 2 over 50, which is the same as 1 over 25. So we can actually just write 1 over 25 straight up. So let's fix that one up. So 1 over 10 minus 6 over 100 is 4 over 100, and 4 over 100 is 1 over 25. And then 1 over 10 plus 6 over 100 is 16 over 100, and 16 over 100 is 8 over 50, or 4 over 25. There we are. So the final answer for the 95% confidence interval is the interval from 1 and 25 all the way to 4 over 25, not including either of the endpoints. And there we go. That is the confidence interval done. Okay, moving on to question 4. Consider the function f from 0 to 2 pi. So we're given a domain here, and the function is a sine x plus b. We are told that the function passes through the points pi over 2, comma 2. So pi over 2, comma 2. And the other point is going to be 3 pi over 2, comma, negative 8. So the question, part A, says, show that a equals 5 and b equals negative 3. All right. So taking the first coordinate, pi over 2, comma 2, we are going to say that the y value is 2, 2 equals, and the x value is pi on 2. So 2 equals sine pi over 2 plus b, and that simplifies to 2 equals, sine of pi on 2 is 1, 1 plus b. Now, there was an a there, so I'll just quickly fix that up. There's meant to be an a in front of the sign. So 2 equals a sine pi over 2 plus b, and then a times sine of pi on 2 is a times 1, which is just a. So 2 equals a plus b, that is equation number 1. Now going to the second coordinate, we will have 3 pi over 2 comma negative 8. This implies this time that negative 8 equals a sine 3 pi over 2 plus b. And in this case, we will have negative 8 equals sine of 3 pi on 2. Well, 3 pi on 2 is on the bottom end of the unit circle, which means sine is negative 1. So that's negative a plus b. And we're going to call that equation 2. So we now have two simultaneous equations, equation 1 and equation 2. So here's equation 1, and there is equation 2. So using our regular rules for simplifying or solving simultaneous equations, we can see that the a's have the opposite sign, so let's add 1 and 2 together. So 1 plus 2, 2 plus negative 8 is negative 6, a plus negative a is of course gone, and b plus b is 2b. So this implies, of course, that b is equal to negative 3. And now, subbing in, b equals negative 3 into, we can look at equation 1, that's probably the easier one. So we will have 2 equals a minus 3, which gives us a is equal to 5. So therefore, at the end, we can finally say that a is equal to 5, and b equals neg 3, which is exactly as required. So that is exactly what the question wanted. They wanted a equals 5 and b equals neg 3, and we provided that information. Excellent. Moving on. So part B. Sketch the graph of y equals fx on the axes below. Label the endpoints and the turning points with their coordinates. Right, so to do this question properly, maybe we should rewrite the function with the a and b values subbed back in. So remember, f of x was a sine x plus b, and a was 5 and b was negative 3. So let's write that out first of all. F of x was a sine, so that's 5 sine of x, plus b, and b was negative 3. So there you go. We are sketching the graph of y equals 5 sine x minus 3 over the domain 0 to 2 pi. So let's write down a couple of facts so first. So the amplitude is equal to 5. So that's just the amplitude of that trig function. The period is going to be 2 pi over the coefficient of x, which is just 1, and that is 2 pi. So we're basically going to be drawing one period of this graph over here. And given that the domain was 0 to 2 pi, so we have exactly one period fitting within that domain. Okay, so given that there's a vertical translation downwards of negative 3, the graph will actually start down there at 0, negative 3. So let's just write that out first of all. 0, negative 3. And also notice that we don't need to find the axes intercepts. So we don't need to find the x-axis intercepts because they would actually be impossible to find given the numbers involved. And then we'll go to the right endpoint, which is right there, and that will also be 2 pi, negative 3. Right, so this is a positive sine graph with an amplitude of 5, so it means from 0, neg 3, it's going to go up by 5, and then right by pi over 2. So neg 3 plus 5 is 2, and that's where we are right now. And then when you go right to pi, it'll come back down to negative 3. And then going another pi on 2 to the right, we're going to go down by a further 5. Neg 3 minus 5 is negative 8. There we are. And now we have all the points that we need to sketch this graph successfully. So let's quickly sketch that. So make sure you have a nice curvature going there to make it look like a proper sine graph. It'll come down and go through there. and then it'll go all the way to the minimum. And then over to the endpoint. All right, so we've got all that there. Let's quickly see what the question wanted. Label the endpoints and the turning points with their coordinates. Okay, so we have to label this as well. That is pi over 2, comma 2. And then on the bottom, we will have 3 pi over 2, comma negative 8. There we are. Okay, so let's double check that. Endpoints and turning points with their coordinates. Yep, we've got the turning points and we've got the endpoints as well. Perfect. Okay, part C. State the values of k for which the equation fx plus k equals 0, where k is an element of R, has no solution for x. So we're looking at fx plus k equals 0, and we want no solution for x. Now, solving the equation fx plus k equals 0, this one right here, is basically the exact same as solving for the x-intercepts of that particular function. So k is a vertical translation. We want to apply a vertical translation and then find the x-intercepts. But not only that, we want no solution for that equation. In other words, we want no x-intercepts. So the way to look at this question now is look at the graph that we already have and ask yourself, what translation can we apply, or vertical translation can we apply to this, so that it has no x-axis intercepts? So first things first, you notice that y equals 2 is the maximum. So if you push the graph down by a number or by a value that's more than 2, the graph will be roughly like that. It would float below the x-axis. So that means that k can be a number that is less than 2. So let me just write that out. So k can be less than negative 2 because we're pushing down by more than 2. So in other words, the k value is going to be less than negative 2. And the other version that we've got, again, let's have a look at this graph again. In this case, we can push the graph up by a value that is more than 8, and then what will then happen is the graph would do something like that. It would float above the x-axis. So in that case, your k value would be a value that is greater than 8. So k greater than 8. So 2 marks over here. I'm going to write that out in interval notation. So therefore, k must be an element of neg infinity, comma negative 2, union with 8, comma infinity. So in other words, k can be any number that's less than negative 2, not including neg 2 of course, or it could be a number that's greater than 8, not including 8. There we go. Right, moving on to the final part of this question, part D. Find the value of m for which the integral from 0 to pi, now this is crucial, the integral is only from 0 to pi, not 0 to 2 pi, of f of x plus m dx equals 0, where m is an element of R. So what this is talking about, in quick terms, is it wants another case of vertical translation, but it wants a vertical translation in such a way that the integral from 0 to pi is 0. So what that refers to is something quite simple. What it wants this area and that area and this area here to basically all cancel out. So it wants this region and this region to add up to a value that equals the area in that region. Because in that case, there'll be an equal amount of area above and below the x-axis, in which case the graph will have an integral of 0. Now, it's pretty much impossible to do this one visually. It would be useful if the integral was from 0 to 2 pi. In that case, the m value would just be 3, because then the graph would just simply do that, and then there would be an equal area above and below. However, in this case, it's only between 0 and pi, so there's a little bit more involved in that one there. So, going back to the question, the only way to do this is just using calculus and algebra. So, let's jump into it. So, we want the integral from 0 to pi of f of x. Now remember, f of x was 5 sine x minus 3, and then we simply add on m at the end. Dx is equal to 0. So, working this one out, 5 sine x integrates to negative 5 cos of x, negative 3 integrates to negative 3x, and positive m integrates to positive mx. And that, of course, has pi on the top, 0 on the bottom, and that equals 0. So, substituting in, we will have negative 5 cos of pi minus 3 pi plus m pi, and then minus, subbing in 0, we will have negative 5 cos of 0 minus 3 times 0 is 0 plus m times 0, that's just 0 as well, and that of course equals 0. Don't forget the equals 0 at the end, because we are basically working through an equation. So, negative 5 cos pi, well, cos of pi is negative 1, so neg 5 times neg 1 is 5, and then we have minus 3 pi plus m pi, so those stay the same. Now, minus negative 5 cos 0, so cos of 0 is 1, so negative 5 cos 0 is simply negative 5, so we have minus negative 5, that is positive 5, and of course all the zeros just drop off, so we have equal 0 there. So now what we have is m pi, because remember we are looking for the value of m, so isolating m pi would equal taking the 3 pi to the right, and then 5 and 5 is 10, and it'll move to the right as a negative 10. And therefore, finally, our last answer is m equals 3 pi minus 10 all over pi. And if you feel like, you can of course rewrite that as 3 minus 10 over pi. And there we have it. That is the value of m. Moving on to question 5. So, in this question, we are considering the function with rule fx equals e to the 1 minus x. That right there is our function. There we are. Okay. So, part A. Simplify f of x over f negative x. Express your answer in the form e to the kx, where k is an integer. Alright, so in this particular case, we're going to write f of x over f of negative x. Now, f of x is equal to e to the 1 minus x, and f of negative x would be e to the 1 minus negative x, which is just e to the 1 plus x. So given that we have the same base, we are going to subtract the powers using our index laws. So that's 1 minus x minus, be careful, please use brackets here, because that will trip up a lot of people, e to the 1 minus x minus all of 1 plus x. So that is equal to e to the 1 minus x minus 1 minus x. Of course, the 1's will cancel out, 1 minus 1 is gone, and we really just have negative x minus x, which is negative 2x. There we go. So we have given the answer in the form e to the kx. In this case, k is equal to negative 2. There is no obligation to actually write k equals negative 2. Part B. Show that f of a times f of b is equal to f of a plus b minus 1. Okay, so this is a functional equation, and the best way to go about showing this is by simply working with the left and right hand side independently. So, the left hand side is equal to f of a times f of b. So what does that simplify to? Well, f of a is 1 e to the 1 minus a, and f of b is e to the 1 minus b. So, because again we have the same base, we can add the powers this time. So that's 1 minus a plus 1 minus b, and that is equal to e to the 1, rather it's 2 this time, because 1 plus 1 is equal to 2. So that's e to the 2, and then negative a and negative b, minus a minus b. That is the left-hand side simplified. Now, the right-hand side is equal to f of a plus b minus 1. So that is equal to e to the 1 minus, now 1 minus x, but in this case x is a plus b minus 1. So that is equal to e to the 1 minus a minus b plus 1, and that is equal to e to the 2 minus a minus b. And if you have a look very quickly at what we've got, we have the left-hand side working out to e to the 2 minus a minus b, the right-hand side working out to e to the 2 minus a minus b. The two of them have aligned up exactly, so therefore we can say the RHS is equal to the LHS, and we have conclusively proved the equation is true. Alright, so moving on now to part C. Solve f of x equals 2 for x, give your answer in the form x equals log e m over n. Alright, so I'm just going to simply write f of x is equal to 2, and from then on we can say e to the 1 minus x is equal to 2. We're now going to log both sides with the base of e, so log e of e to the 1 minus x is equal to log e of 2. Now, using our log laws, the 1 minus x will jump out the front. So 1 minus x, please use brackets for that. Log e of e is of course equal to log e of 2. Right, now log e of e, that's just 1. So what we've really got is just 1 minus x equals log e of 2. And now, using some algebra, we can take x to the right and log e2 to the left. So we have 1 minus log e of 2 is equal to x. So we've got the value of x. However, it's not in the form that we require. So in order to get into that form that we require, I'm going to rewrite x, and instead of writing 1, I'm actually going to write log e of e. So that's log e of e minus log e of 2. And now that we've got log e of e minus log e of 2, the bases are the same and we don't have any other coefficients in front of the logs. So what we really got is x equals log e of simply e divided by 2. And that now corresponds with exactly the way the question wanted the answer to be stated, which is log e of m over n. Excellent. And that's it. That's it for question 5. Moving on to question number 6. In a particular city, the probability that it will snow on Monday is x squared. So let's just highlight that fact. So Monday snow is x squared. Now, if it does snow on Monday, so we've got a conditional here. So if it snows on Monday, then the probability it will snow on Tuesday is 1/4 x. So that 1/4 x depends on snow on Monday. Now, if it does not snow on Monday, the probability it will snow on Tuesday is going to be x. So, first part, part A, part 1, find an expression in terms of x that gives the probability that it will snow on both Monday and Tuesday. Okay, so first, before we go and answer this question, it's always good to draw a tree diagram because these are sequential events. So if it rains on Monday or not Monday, we're going to call it m. So the probability of snow on Monday is x squared. Therefore, there will be a 1 minus x squared probability of not snow on Monday. If it does snow on Monday, it will snow on Tuesday with a probability of 1/4 x, and therefore we will have 1 minus 1/4 x chance of not rain on Tuesday. In a similar manner, if it does not rain on Monday, then the probability it will snow on Tuesday is x, that will be x on the top, and then the probability of no rain on Tuesday, following no rain on Monday, is going to be 1 minus x. Excellent, so now moving on to the question, we want the probability that it will snow on both Monday and Tuesday. In other words, it wants m intersection t. So to do this, we simply are going to move across the tree diagram from left to right, like this. So Monday we want, and we want Tuesday right there. So it's going to be x squared. So x squared multiplied by 1/4 x. And that will be, of course, 1/4 x cubed. There we have it. So that's the probability that they want. Moving on to part 2. Find the value of x if there is a 25% chance that it will snow on both Monday and Tuesday. So It's the exact same probability, but now they're telling us it is 25%. So PR of M intersection T is equal to 25%. Now 25% is the same, of course, as 25 over 100, which simplifies nice and easily to 1/4. So therefore, we want 1/4 equals 1/4 x cubed, which implies that 1 equals x cubed, which implies again that x is equal to 1. And the question wants the value of x. We have given it the value of x. Perfect, and that's all you need to do. Right, moving on to part B, part 1. Find an expression in terms of x that gives the probability that it will snow on Tuesday. Now, if you look at this question here, it just wants the probability of snow on Tuesday. It doesn't care about what's happening on Monday. So for this one, there are two different ways to get to snow on Tuesday. We can either have snow on Monday followed by Tuesday, or we can have no snow on Monday, followed then, of course, by snow on Tuesday. So, working this one out, we just want PR of T. So, PR of Tuesday rain is equal to, it's going to be x squared times 1/4 x, x squared times 1/4 x, plus 1 minus x squared times x. So make sure you put the 1 minus x squared in brackets. 1 minus x squared times x. Now, simplifying all that, we will have the usual 1/4 x cubed, which is what we saw before, plus 1 times x is x, minus x squared times x is x cubed, and that is equal to, the x will remain as it is, and 1/4 x cubed minus x cubed, they're like terms, that will become negative 3/4 x cubed, and that's it. That's the expression in terms of x for the probability it will snow on Tuesday. Part 2. Find the value of x that will result in the highest probability that it will snow on Tuesday, and find the probability for this value of x in the form a over b. Okay, so what we've got now is this probability of t, and we want that to be maximized. So what we're going to do is I'm going to let capital P equals this probability of snow on Tuesday. That will equal x minus 3/4 x cubed. And remember, we want to maximize this quantity. So we're going to use calculus and work out the derivative. So dp dx is going to be 1, so x differentiates to 1, and 3/4 x cubed differentiates to 9/4 x squared. Excellent. Now, because our job is to find p max, we want the maximum value of p. So for p max, we want this derivative, dp dx, we want that derivative to equal 0. So 0 equals 1 minus 9/4 x squared. This will be 1 equals 9/4 x squared, or in simple terms, 4/9 equals x squared. So evaluating that, we will get x equals plus minus 2/3. But x is a probability, so therefore it needs to be greater than 0, and therefore x equals 2/3. So the value of x is 2/3. So we have found the value of x. Check, that will result in the highest probability. And find the probability for this value of x in the form a over b. So therefore, our actual max probability is the value of PRT when x is 2/3. So that will be 2/3, which is x minus 3/4 times x cubed, which is 2/3 cubed. So now we just need to work out this quantity here. So that's 2/3 minus 3/4 times 2 cubed is 8 over 3 cubed is 27. So now we can do some cancelling. The 4 and the 8 become 1 and 2, and the 3 and 27 become 1 and 9. So what we're left with is 2/3 minus 1 times 2 is 2 over 9. 2/3 minus 2 over 9 is basically times by 3, so it's 6 over 9 minus 2 over 9, which is 4 over 9. So now, given there's a lot going into this question, I'm just going to quickly highlight our answers. So the x value they were after is x equals 2/3, and the probability for this value, the p max value, is 4 over 9. So I'll just highlight, p max, and that is equal to 4 over 9. Perfect. All right, moving on to question number 7. So consider the function p, where p has a domain of 1 to infinity, and p of x is this big quartic function right there. Part 1. Find the value of a when the inverse at a is equal to 2, where a is an element of R. Okay, now given that this is just simply a 2 marker, it doesn't make sense that we'd have to actually go and calculate the inverse and then sub in x equals a. That's probably a bit too complicated for what we need. In fact, what we need to do is use the fact that for an inverse, x and y is swapped. So if p neg 1 of a is equal to 2, so let me just write that out. If the inverse at x equals a is equal to 2, this is the same information as the original evaluated at x equals 2 is equal to a y value of a. So as you can see, x value a, y value 2 has now changed into x value 2, y value a. So that's just taking advantage of the fact that the inverse has x and y swapped. So therefore, we know that a is equal to p of 2, and simply we need to sub in 2 into p of x. So that's 2 to the 4 minus 2 cubed minus 2 squared plus 2 plus 1. 2 to the 4 is 16, minus 2 cubed is 8, minus 2 squared is 4, plus 2 plus 1 is 3. 16 minus 8 is 8, 8 minus 4 is 4, 4 plus 3 is 7. There we go. So the value of a is 7. Right, moving on to part 2. Find the value of b when p of b is equal to 1, where b is greater than 0. Okay, so here I'm going to take the function, so p of b, and basically just chuck in x equals b in all the x appearances. So that's going to be b to the 4 minus b cubed minus b squared plus b, and then of course plus 1, and we need that to equal 1. So just minusing 1 from both sides will give us a 0 on the right hand side, which is just what we need. So b4 minus b cubed minus b squared plus b is equal to 0. Now that is quite a complicated equation. It is still a quartic. However, we do have a little bit of help our way in the sense that this can actually be grouped. So I'm just going to highlight in different colors what we can group. So b4 minus b cubed, we can group those together, and then the negative b squared plus b, we can group those together as well. So grouping the first two, we will have b cubed is the common factor, bracket b minus 1, minus is now the common factor, minus b, and the negative b times b is b squared, and negative b times negative 1 is positive b. So there we go. We now have a common factor of b minus 1, and the remainder is going to be b cubed minus b, and that equals 0. So we will have b minus 1, and then take common factor of b out of that, and b squared minus 1 equals 0. And we'll do one more factorizing round before we can get the answer. So that's going to be b minus 1 times b minus 1, and then b plus 1. What a factorization. So now we have b is equal to 1, b equals 0, and b equals negative 1. However, please keep in mind the restriction in the question, and that is b is greater than 0. So therefore, since b is greater than 0, the value of b is going to equal, well, we have 1, 0, and negative 1. The only one that's strictly greater than 0 is b equals 1, and that is our answer. Excellent. So moving on to part B, find the rule and the domain of the inverse of f if the original function is x plus 3 over x minus 2. Right, so this is just a straightforward stock standard inverse function question. So I'm going to start by saying let y equal the function, let y equal fx equal x plus 3 over x minus 2. So I'm just letting y equal f of x to enable us to do some swapping. I'm going to say for inverse, this is crucial, you must write this line, for inverse, swap x and y. So now what we'll have is x is equal to y plus 3 over y minus 2. And then we're going to solve for y. So this implies multiplying both sides by y minus 2, x bracket y minus 2 is equal to y plus 3, multiplying the left-hand side, xy minus 2x equals y plus 3. And remember, we want y by itself. So let's bring the y from the right to the left, and let's take the x from the left to the right. Now we'll factorize out y bracket x minus 1 equals 2x plus 3, and therefore we will have y equals 2x plus 3 over x minus 1. So what does this lead to? Well, what we can say is, therefore, the inverse function, so f inverse of x, is equal to 2x plus 3 over x minus 1. And we also want the domain of the inverse. So the domain of f neg 1 is equal to, so notice over here in the original how the domain was all reals excluding 2, and we had an x minus 2 on the bottom. The same idea here, we have x minus 1 on the bottom, so the domain of the inverse is going to be all reals except positive 1. So there we go. So all real numbers except 1 is the domain of the inverse function. Perfect. Right, moving on to question 8. I believe this is the last question on the paper. Part of the graph of the function f, where f is from neg infinity to 0. So we've only got negative numbers and 0 in the domain, and we've got the product of e to the x and sine x. And they've given us the graph, which is really good. So part A, find the general solution to fx equals 0. So when they say general solution, this implies that we've got some parameter involved in the answer. And that makes sense because this graph will actually have infinitely many x-intercepts. So it has an x-intercept, of course, at 0, it has one here, it has one here, and it'll keep having x-intercepts all the way to the left as you go more negative. So that's something to keep in mind. We want a general solution rather than some specific solutions. So fx equals 0 is the same as e to the x sine x equals 0. Now we can actually divide both sides by e to the x because e to the x is a function that is always positive. So that means we just have sine x equals 0. I'll just double checking that, as e to the x is greater than 0. So e to the x can never equal 0, so we are allowed to divide by it. If that was x instead, or x squared or something similar, then it would be impossible to go and divide by that because you're not allowed to divide by 0. So as e to the x is greater than 0. There we go. Right, so we want the general solution to sine x equals 0. So for this question here, let's quickly draw a unit circle. sine x is equal to 0 at 2 points. It's either on the right or on the left. Now, those 2 points are generated by simply any integer multiple of pi. So that is x equals n pi, where n is an element of z. Now, this is crucial. You have to write an element of z, otherwise you don't get just integers. So for any multiple of pi, so basically pi, 2 pi, 3 pi, etc., we want that. However, make sure that you look back at the domain. This domain's from -infinity to 0, remember that? So we don't want just any integer, we want just the positive integers, so we're going to call that z plus. However, 0 is also included, that intercept right there, the one at the origin. There we are, so that intercept at the origin. Now z plus, or z minus I should say, does not include the 0 number. So we're going to have n element of z minus, and we're going to union the number 0. So in other words, n is all negative integers as well as the number 0. And that is the general solution to that equation. Now, in part B, find the general solution to f dash x equals 0. So first things first, let's work out the derivative itself. That's going to be a good start. So the derivative f dash of x. Remember, f of x was this one right here, the product of e and sine. So therefore, we're going to use the product rule. So differentiate the first, e to the x differentiates to itself, multiplied by the second, plus differentiate the second, which is cos of x, multiplied by the first, which is e to the x. So I'm just going to simplify that, and I'll actually also factorize out e to the x. So that's going to equal e to the x, so e to the x, and factorizing out, we get sine of x plus cos of x. There you go, that is the derivative. So now, equating that to 0, f dash x equals 0 implies that e to the x, bracket, sine x plus cos x is equal to 0. And for a similar reason, we can drop the e to the x, we can divide both sides by it. So we end up with sine x plus cos x is equal to 0. So taking the cos to the right-hand side, sine x equals negative cos of x. And just taking that a couple steps further, dividing both sides by cos, sine divided by cos is tan. So we end up with tan x equaling -1. So again, in a similar fashion, we are going to work out the general solution to this particular equation. So tan x equals -1. Let's just draw a quick unit circle on the bottom left over here. When tan x equals -1, we're looking at quadrants 2 and 4. Let's just make that look a little bit better. There we go. Now the reference angle for this particular diagram is equal to pi on 4. That's because tan of pi on 4 is 1. So we are in quadrant 2 and 4 with a reference angle of pi on 4. So in order to basically get these answers, we need to have x equals, now again, similar deal as before, you can start at either pi, so 0 pi, 2 pi, 3 pi, 4 pi, etc. And all we've got to do after that is rotate clockwise by pi on 4. So that means we have x equals n pi, so n pi will get us to the left or the right, and then we subtract pi on 4 from there. So that's what that means now, is that x is, of course, n pi minus pi on 4, and in a similar way as what we did in part A, the values of n are again going to be all negative integers, so z negative, union 0. Now just double check that 0 does give you a negative value for x. If you put in 0, You get n pi, which is 0 pi, that's gone, neg pi on 4. There you go. So neg pi on 4 would be the first solution. Then, of course, neg pi minus pi on 4, there'll be neg 5 pi on 4, and then you keep going more negative after that. There we are. So we have the general solution to the derivative equals 0 in terms of the parameter n. Right, C part 1. Show that ddx of ex sine x minus ex cos x is equal to 2ex sine x. So this one is basically a derivative where we need to work out the derivative of the left-hand side. So what we're going to do is we're going to say LHS equals, and just jump right into the derivative. So we're going to use the product rule on this and on that, and be careful with some brackets as well. So differentiate the first times the second plus differentiate the second, which is cos x, times the first, minus, now repeat the same thing for e to the x cos x, differentiate the first times the second, plus differentiate the second. Now the derivative of cos is negative sign, neg sign, times the first, which is e to the x. So I'll just put that negative sign in a bracket, like that. Right, now let's work this one out. So we'll have e to the x sine x plus e to the x cos x. Now multiplying the negative into the other bracket, that's just minus e to the x cos x, and we have negative, positive, negative, so that basically becomes a positive e to the x sine x. There we go. So where can we do any cancellations? There we have it. So the e to the x cos x here and the minus e to the x cos x, they cancel out. I'm just going to remove that because we need to show it still. So that is equal to, those parts, the causes are gone. So we have e to the x sine x plus e to the x sine x, which is the same as twice the same thing. Just 2e to the x sine of x. And there we have it. That is equal to the right-hand side. We have proved it. So the 1 mark is just for showing evidence of usage of the product rule twice. Okay, part 2. Hence find the area bounded by the graph of the function f and the horizontal axis over the interval negative pi to 0. Okay, so let's look back at the graph of this one here. So we have a graph here, and we want from negative pi to 0, we want the area. Okay, so let's look at the general solution. X equals n pi, which means that this is going to be 0, that's going to be pi, that's going to be 2 pi, etc. So this question wants this area between negative pi and 0. There we go. So it wants that specific area right there. That's it. So clearly it is below the x-axis, which means the integral will need to have a negative in front of it. So here we are. The area is equal to the negative integral from negative pi to 0 of the function e to the x sine x dx with respect to x right there. Right, so we can get rid of the negative by performing one simple little trick. You can basically change the terminals. So 0 on the bottom, neg pi on the top. That makes it slightly easier to work out what's going on. So e to the x sine of x dx. Right, so what is the integral of e to the x sine x? Because that is not something that we can do straight off the cuff or by hand. You need to look back at part C, part 1. We were told that if you differentiate that big term, e to the x sine x minus e to the x cos x, you will end up with 2 e to the x sine x, which means if you integrate this, if you integrate that function right there, you will get the left-hand side, you will get that function right there. But we don't have 2 e to the x, we have just e to the x. So our integral is going to equal half of the left-hand side in part C, part 1. Doing that, so we will get 1 half, and then we can put our square brackets. It's going to be e to the x, and we have e to the x happen twice actually, so we can just factorize it out, just make it a little bit easier for us. E to the x sine x minus cos x, not with respect to x, we need to put a square bracket. So square bracket, negative pi on the top, and 0 on the bottom. There you go. And now all we have to do is just work this out 1 by 1. So that's equal to half subbing in neg pi, e to the negative pi. Now, sine of x, sine of negative pi, that is 0, minus cos of negative pi. Cos of neg pi is the same as cos of pi, which is negative 1. So minus minus 1 is plus 1. Now subbing in 0, minus half. E to the 0 is 1. So I'll just write e to the 0 actually for now. E to the 0. Subbing in 0 into sine of x is of course 0. Minus cos of x minus cos of 0 is negative 1. So that's together, and then finally the close bracket for the half. So that's 1 half. E to the negative pi times 1 is just e to the negative pi. And then we have negative half times e to the 0 is just 1. 1 times neg 1 is neg 1. Neg half times neg 1 is positive half. So what we end up with here is half e to negative pi plus half. So that's just e to the negative pi plus 1 all over 2. And we're going to write units squared because it is an area. There we have it. So e to negative pi plus 1 all over 2. Excellent. And I believe this is the last part. Yep, last question. Part D. Consider the function g r to r, where g of x is negative 2e to the pi over 1 plus e to the pi. That looks like a constant to me, times ex sine of x. So this one right here, that's just a constant. It's just a coefficient in front of the e to the x. Let me just write that out. Just a constant. Okay, and it is only from negative pi to 0. So this is a continuous random variable as well. So we are told that this is a continuous random variable x with a PDF g given by that function up there. So if xm is the value of x for which g has a maximum value, find PR of x less than xm. Okay, so we actually do have a hint about this question because that constant, as I've highlighted, is a negative number, which means when you go back to this function over here, this entire bottom part that's highlighted is flipped upside down. So I'm actually going to just quickly sketch that so we can see what's going on. So this is what it looks like, and that part of the function is actually just looks like this. There. So that's 0 over here. See that? So there's 0, and there is negative pi. So that's what g of x roughly what it looks like. xm is the value of x for which g has a maximum value. So we're looking at this value right here, and we're calling that xm. So can we work out what xm is? Because you can't work out the question without knowing what xm is. And the answer is yes. Because if you look back at part B, we had a general solution to f dash x equals 0, and it was this function right here. N pi minus pi and 4 for all negative integers, including 0. So the first set, the first member of that set, I guess if you look from the right, is n equals 0. So if you plug in n equals 0 into there, you'll get 0 pi minus pi and 4, or in other words, you just get negative pi and 4. So negative pi and 4 is the x value of that local maximum over there. So I'm just going to write negative pi over 4. So our first line of working is from part B, xm would equal neg pi and 4. So therefore, PR of x less than xm equals PR of x less than negative pi on 4, and this would equal the integral. So negative pi on 4 over there, we want that particular area, the one on the right. So the integral will start at negative pi, end at negative pi on 4, and then basically put this entire function in there. So negative 2e to the pi over 1 plus e to the pi, and then of course e to the x sine x dx. Right, so to work this one out, we need to do a little bit of algebra. So I'm going to take that constant out because having that inside there will make the maths unnecessarily complicated. Neg 2e pi over 1 plus e to the pi. And then this integral will evaluate to half. Basically, we're repeating the calculation we did back up in part 2, where we reversed the derivative that we saw in the previous part. So half, and e to the x sine x becomes half e to the x, and I think it was sine plus, no, it's sine minus cos. Yeah, so sine minus cos. So sine x minus cos of x. And then we're going to have negative pi on 4 on the top. And then negative pi on the bottom. So we need to now work out the integral itself. So first things first, we can see that the 2 and the 2 can cancel out. So let's just get rid of those. And we end up with negative e to the pi over 1 plus e to the pi. And then we need to start subbing in the negative pi on 4 into the big bracket. So I'm just got a big bracket here, and then plug the neg pi on 4. So that's e to the negative pi on 4. And let's just work out what sine and cos of negative pi on 4 are individually. So sine of neg pi on 4, that's just negative root 2 on 2. It's in the fourth quadrant. And then cos of neg pi on 4, that's just cos of pi on 4. That's root 2 on 2, but it's being minused, so we'll put a minus there as well. So that's just the neg pi on 4 subbed in. Now let's plug in negative pi. So this case, we're going to have e to the negative pi. This is quite a large working out, so we have to be careful with how we go about things. Sine of neg pi, well, sine of pi, sine neg pi, that is 0. So that's 0 there. Minus cos of neg pi. Now, cos of negative pi is the same as cos of pi, which is negative 1, but we have a minus in front of it, so that's minus negative 1, which is going to be positive 1. So closing that bracket there, and then we'll close the big bracket, which is multiplying by the coefficient at the front. Okay, so this time we have negative e to the pi over 1 plus e to the pi, and then in the bracket we have e to the negative pi on 4. Now negative root 2 on 2 minus root 2 on 2, that's just twice root 2 on 2, or twice negative root 2 on 2 I should say. So that's going to be just negative root 2. And then negative e to the negative pi times 1 is simply negative e to the negative pi, and times 1 we'll just leave that out. And here we have it. So what we've now got is we can multiply we can get rid of all the negatives inside the bracket. So we will have e to the pi over 1 plus e to the pi multiplied by, and get rid of the negatives, so it'll be root 2 e to the negative pi on 4, and then plus e to the negative pi. So we can simplify that just one last stage. So we're going to have 1 plus e to the pi on the bottom. One plus e to the pi on the bottom, and multiplying e to the pi through, So e to the pi times e to the negative pi on 4. So the root 2 will stay there. And e to the pi times e to the negative pi on 4, that's e to the 3 pi over 4. And then e to the pi times e to the negative pi, well, that is just 1. And there we have it. Our final answer, I'll just highlight that just for clarity, is e to the root 2, e to the 3 pi on 4, plus 1 all over 1 plus e to the pi. It's quite a large and gnarly answer, I've gotta admit, not gonna lie, but there we go, that is the answer to the question. And guess what? That is the end of the exam. Right, that was quite a tough one. At least towards the end, it got a little tough. The algebra just got a little bit hard to deal with. But there we go. That's the end of the exam. So I hope you got something out of that. Thanks for tuning in, and look forward to the next suite of videos. Thanks everyone. Cheers.